All right, let's dive right into OpenShift's core architecture. We're going to follow the entire journey of an application, from the moment you write the code to the service your users actually see. And we're going to uncover all the magic that happens in between. It's something we all kind of take for granted. You write your code, you push a button, and it just works. But behind that one simple action, there's this incredibly sophisticated dance of components that makes sure your application is stable, scalable, and resilient. So let's pull back the curtain and see how it all comes together. So here's how we're going to break this down. First, we're going to look at the most fundamental building block, the pod. Then we'll get into how an application actually remembers things with persistent storage. After that, we'll figure out how it talks to the outside world through networking. And finally, we'll put that whole picture together. Okay, so every single application's journey in OpenShift starts right here with the pod. And this isn't just some technical term, it's literally the birthplace of your running code. So what on earth is a pod? Well, it's the most basic, the smallest thing you can possibly deploy. Think of it like a wrapper around your application's containers. It gives them a shared home, a shared environment, including their own unique network IP and storage. It's really the fundamental atom of the entire OpenShift universe. Creating a pod isn't random, it's a carefully orchestrated process. First, your request hits the API server, which basically acts as the gatekeeper, making sure everything looks right. Once it gets the green light, the scheduler steps in. Its job is to play matchmaker, finding the absolute perfect worker node with just enough CPU and memory for your pod. And finally, the kubelet on that chosen node gets the command and makes it all happen, making sure your containers spin up and start running. Okay, so our application is live. It's running inside a pod. But an application without a memory is pretty limited, right? What happens to all its data? To be truly useful, we need to give it a memory that actually lasts. And this is such a critical question. You see, pods are designed to be ephemeral. That's a fancy word for temporary. They can be replaced, restarted, or moved at any time. So if your data lives inside the pod, it just vanishes with it. And that's a huge, huge problem for any serious application. So how does OpenShift solve this? Well, the first piece of the puzzle is something called the persistent volume, or PV. You can think of this as just a big pool of available storage resources. An admin sets up these volumes. They might be super fast SSDs or big old hard drives and gets them ready for applications to use. It's basically the supply closet of storage for the whole cluster. Now for the second piece, the persistent volume claim, or PVC. So if the PV is the supply, the PVC is the request. This is your application raising its hand and saying, hey, I need 10 gigabytes of that fast storage, please. The PVC then goes and finds a matching PV from that supply closet and binds to it. And this relationship between the two is just key. On one side, you've got the persistent volume. That's the actual physical storage just sitting there. On the other side, you have the persistent volume claim. That's your application's request for a piece of it. This separation is so powerful because it completely decouples your application's need for data from the actual hardware underneath. That is a massive shift from traditional IT, where your app was just stuck, tied to a specific machine's hard drive. And here it is, the most crucial takeaway, because your application's pod connects to a claim for storage, not the storage itself. Their life cycles are totally separate. The pod can crash, it can get replaced, whatever. But that claim, and more importantly, your data, remains safe and sound, ready for the next pod to come along. In essence, your data outlives your code. So we're in a good spot. Our application is running, and its data is totally safe. But it's still living in a bubble. The final step in its journey is to connect to the outside world so that users and other services can actually talk to it. Right? Pods have their own internal IP addresses. But, and here's the catch, those IPs can change every single time a pod gets recreated. You can't give that unstable address to your users. It'd be like trying to give someone directions to a house that moves every 5 minutes. We need a stable, reliable way for traffic to find our application, no matter what's happening to the pods behind the scenes. OpenShift solves this with a few clever layers of networking. At the very bottom, you've got the pod IP. That's just for internal chatter between pods. Now, the next layer up is the service, and this is a total game changer. Think of a service as a stable internal load balancer. It gives you a single, unchanging IP address for a whole group of pods that might be constantly changing. Traffic goes to the service, and the service is smart enough to forward it to a healthy pod. And finally, for traffic from the outside world, you have a route, which gives your service a public name, like myapp.example.com. So let's actually trace a request from start to finish. A user types your app's URL into their browser. That request first hits the cluster's ingress controller. That's the main traffic cop, the front door for everything coming in. The controller looks at the host name and says, aha, I know where this goes, and passes the request to the correct route. The route then points it to the right service. And finally, the service forwards that traffic to one of the available healthy pods. And boom, your application code gets the request. It's just a clean, reliable, and totally scalable journey. Okay, we've covered a lot of ground. Now let's put all the pieces together and look at the complete picture of our application's life inside OpenShift. And this really shows how these three pillars work in perfect harmony. At the very foundation, you've got your application running in pods. That's your core compute unit. Then those pods connect to persistent storage using claims, making sure your data can survive anything. And at the very top, all of that is exposed to the world through a super stable networking layer of services and routes. It's this beautiful combination of compute, storage, and networking that creates such a powerful and resilient platform. So if you remember just 3 things from all this, make it these. 1. Pods are the basic home where your code lives and runs. 2. Persistent volumes and claims give your application a permanent memory, separating your data from your code. And 3, services and routes act as the stable front door, letting users reliably connect to your app every time. See, understanding these fundamental building blocks is really the key to unlocking the full power of a platform like OpenShift. It's not just about running code anymore. It's about building resilient, scalable, data-driven applications that can do amazing things. The only question left is, what will you build?